Hello again, everybody. This is Tom from Every Step Calculus, everystepphysics.com. This is another partial fraction decomposition problem. You can see on the screen here x5 is the numerator and this is the denominator. And of course, if you get that, if it's factorable, then you can use partial fraction decomposition. It has to be factored, the denominator, into one or a couple parts, factors. So let's do it. Let's see how my program works on this. Index 8 to get to my main menu. When you buy my programs, I download them to you, via email, zip file. And you open that up, and then you have instructions on how to work my programs, and it tells you how to put index 8 here with open and close parentheses to get the main menu and the program to run. We press, here's the menu here. We're at the P section. Notice it's very long, the menu, A to Z, of everything you need to know about calculus. And same thing with physics. These menus are important because, like, for instance, if you get a problem that says you want to do partial fraction, you go to partial fraction in the menu. That gets you started on it. You enter the integral in here. This would be x5 divided by x4, x squared 16 dx. And you have to press alpha first to do that, to put in letters. Put in whatever into my entry lines here. You have to press alpha first, so remember that. I've already entered this in here to save time with the video, so that's the reason that I'm not doing it here with it. If I did it, here it gets complicated. Sometimes the simulator messes up, so I've entered it in already here. And it'll look just like this if you enter it yourself into your calculator after you load my programs in there. And I give you a chance to change it in case you've made a mistake. You can go back and change whatever you're entering into these lines. I've always made sure I've done that. And I factor automatically. The calculator does that of any denominator, and if it's factorable, then it goes to partial fraction decomposition to work it. Now in this case, because the numerator is higher in order than the denominator, we have to use long division. So we set it up like this. Here's x5 divided by this here, right? The first thing we do, we divide x5 by x4, which equals x. So that's the quotient, the first answer, quotient. You put that on top, as you do with any long division. You put the x on top. I can't do it because of the screen requirements here on the calculator, but I tell you what you're going to do, and then if you've done any long division at all, you know that you're going to put x up here, and you're going to make a big line with the, and put the different aspects of the long division under the lines and whatever you need to do here. So here's the x on top. Here's what the divisor is here, x5, and you have to add, just because there's x5 and you have to add the x4, x3, x2, x1, and 0. And then we multiply that x times the divisor over here, and we get up x5 and 8x cubed plus 16x. We subtract that from here, and we come up with minus 8x cubed and minus 16x. Now, because the 8x cubed is lower in order than the x4, this becomes the remainder. All right. Now we set up the problem. on the left side of the equation, which is x5. We multiply the denominators. We're trying to get rid of the denominators here in partial fractions, so we multiply the denominator times the x5 to get rid of that. That'll cancel. And then for the right side, we do the same thing, except we're using the factored denominator here, which is right over here. This factors to x squared plus 4, the quantity squared. Here's the way it looks on your paper. You're going to do it. And eliminate the ax plus b denominator. And of course this can be ax squared plus 4 times ax squared plus 4 right here. So when you get 1 cancels, so we have ax plus b plus x squared plus 4. And then we eliminate the denominator of cx plus d, and since they're the same, it equals cx plus d only. Now when long division is used, the remainder of the long division becomes the where we equate the coefficients on the left side with the right side. So ax cubed minus 16x equals ax plus b times ax squared plus 4 plus cx plus d. So this is the left side of the equation. Now this is the remainder, remember, of long division, and this is what our partial fractions have turned out to be. We're going to multiply x plus b times x squared plus 4 to clean that up here now. In this case, we use that FOIL method, you know, first, outside, inside, and last method, and we come up with this right here. So we combine like terms, and we come up with ax cubed and bx squared and 4a plus c times x and 4b plus d. Now we equate the coefficients. Notice on the x side, on the left side is minus 8 x cubed, and here's a x cubed, so then a is going to equal minus 8. 0 for x squared, and here's b x squared. B is equal to 0 then. Here's 16 minus 16x is equal to 4a plus c. We eliminate because I'm the same on both sides as the x. We can eliminate that. And then we sub in a, which is minus 8 minus 16 equals minus 32 plus c here. Bring that to the other side, changing signs, and we turn out with c is equal to 16. This is automatically done with my program. And 0 is equal to the constants on the right side, 4b plus d. We substitute b in here, which is 0, eliminates this. So d is equal to 0. Here's the original partials we've created. And now we're gonna substitute for a and c in here. Minus 8x and 16x plus 0. Here's b was 0, remember, and d was 0. And so now we're going to integrate these. Okay, so the first integral is minus 8x over x squared plus 4 dx. 16x, the next one is 16x x squared over 4 to the quantity squared dx, and then we have our quotient from the long division x dx, right? So we integrate these three. You can write this on your paper and show you what you're doing. You're going to use substitution. And we back sub u, and we get minus 4 times log of x squared plus 4 plus c. Now we do the second integral that we've created, 16x over x squared plus 4 to the quantity squared. We're going to use u substitution again. Because there's an x on the numerator, we can use u substitution. when you differentiate x squared, of course, you get 2x, right? And so then you can match 2x with in the numerator, and that's what use substitution always does. Constant out of the integral first. Always do that when you're integrating. And then use substitution, x squared plus 4. And then, because this isn't exactly 2x, is not like the numerator, we needed to separate that, so we take the 2 and divide the other left side, right? And then we put in our u's, like here, substitute for u's. We integrate, and then we back substitute. So here's the answer, minus 8 over x squared plus 4 plus c. And then we're going to integrate the quotient of the long division, which is x, integration of x is equal to x squared over 2 plus c. So the original problem here equals x squared over 2 minus 4 log x squared over plus 4, etc. here, plus c. That's the answer. Pretty neat, huh? Everystepcalculus.com. Go to my site, buy my programs, and pass calculus. It's as simple as that. I'll help you also. You know, you can call me and talk to me in person, or you can email me. I'll help you with your problems or show you how my programs work, or whatever, or how to load them, whatever you need. I will help you. I'm interested in you passing calculus, just like I designed these for me to pass calculus, and I got A's in all my calculus classes. I got an A's in all my classes, to tell you the truth, because of these programs. I was a electronic major. It was my major in San Diego State, and I programmed everything, because it's just amazing how this calculator can do this type of stuff. Okay, still amazes me, and I've done it for 30 years. So go to my site, buy my programs, and pass calculus. I'll help you. Have a good one.